Hello students. This is a simple demonstration of the power of subprograms. I'm creating a project using Microsoft Visual C++ 2010 Express Edition, but the concepts are exactly the same if you're using Dev C++. So I've created a project called Subprograms, and I need a source file to create my program, so I'm going to add one. It's also going to be called Subprograms. First thing I'm going to do is create my main function, the entry point for my program. I'm going to end off the main with a system pause call so that the program will wait for user input before closing. In order to use the system call, I need the standard lib, and I'm going to add a little comment after the include to let myself know why I included this library. And now I'm going to print something out. If you notice, cout and end line are both underlined in red. That's because the compiler doesn't recognize them. I need to include the IOStream library. And they're still underlined in red, and that's because they're part of the standard namespace. So I need to let the compiler know about that as well. And while I'm busy documenting, I might as well add a block comment above my main function to tell whoever's reading it that this is the entry point for the program. And that's it. Compile and run, and we have our Hello World program. Alright, now I need to modify the body of my main function to do something different. I'm going to be doing some integer division, so I need some variables to use, int x and int y. Those will be my divisor and my dividend, and I'm going to be calculating the quotient and the remainder of the division. So I'm going to declare one variable for each of those. And then I'm going to do the calculations. First, I need a value for x and y. So I'm just going to choose a couple of random values. And then I'm going to calculate the quotient and remainder. Now I've done the calculations, I'm going to print out the result. That should be the end of my first example. Now I'll compile and run, And 14 divided by 3, the quotient is 4 and the remainder is 2. Now I want to do a few more examples, so I'm going to copy and paste that one and then just modify the x and y values. Compile and run, and we'll see the result of those 3 examples. I forgot to put an end of line character in my first example, so now when I've copied and pasted, I actually have 3 missing end of line characters, so now I have to add those in 3 times. If I had made 100 examples, I would have to fix 100 different places where I forgot to put that end of line character. Now it looks good. Now I'm going to show you why it's valuable to know how to write subprograms. Because if I had done like 100 examples, this program would be really, really long the way I've done it. But what we can do is we can take all the work and put it into one subprogram, and with a single line call we can repeat all the work. You'll see what I mean when we get through the example. But first I'm going to write a block comment describing what my subprogram will do. It's going to divide x by y and print out the quotient and remainder. So first I'll declare void. Void means that my subprogram is not going to return anything. Divide is the name of my function, and int x and int y are the input to the function. Input could be also called parameters or arguments to the subprogram. And you might hear me use the word function instead of subprogram. Sometimes it's because functions are a type of subprogram. So I've copied and pasted a chunk of my main into my subprogram. So the first part does the calculations and the second part prints out the result. And that's my completed subprogram. Now I'll show you how to use it. First I type the name of my function. I'll call it subprogram, the name of my subprogram, and then I'll supply the arguments to the subprogram. And you can see the first 2 lines print out the same thing. So the first line comes from my subprogram and the second line came from my old example. Since they did the same thing, I've erased my example. And now I'm going to also replace the other examples with single line statements which invoke the subprogram. Now you can see I'm going to replace about 30 lines of code with 3 lines of code. But when I compile and run my program, it's going to print out the exact same thing as before. So that's why subprograms are important, because you can do tons of work with a lot less code. And if you want to add additional examples, you can do it with a single line statement. I'll just modify the values to print out different things, do different calculations. And there we go, a couple more examples with 2 more lines of code. Now we saw that int x and int y were the arguments to the subprogram. You don't have to provide 2 arguments. You could have 0, 1, 2, 3, as many as you'd like. So I'm going to add an extra one on there, a string, just to print out. Now if you look at the 5 lines in the main body, you can see there's a little red underline at the end of each function call, or each subprogram call. And it's because we added another argument to our subprogram, and now the compiler is looking for it. So I have to add an extra argument. And now the compiler is telling me that it doesn't recognize using cout with a string, so I have to include the string library. Now the little red squiggly disappeared, so the compiler is happy now. Compile and run, and we've printed out an extra string at the end of our line that we've printed out. I'm going to document my subprogram. I'm just going to list each of the parameters and what they're for, because if someone else wants to use this subprogram, they don't want to have to experiment with it. They want to just be able to look at it and read with plain English. Okay, this is what it does, and this is what I need to provide in order to use the subprogram. And that's it. Compile and run one more time. All good.